1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14, 15, 16, 17, 18. Okay. And we look at, if we wanted to, we could look at her VO2. Her VO2 went from 0.8 all the way up to 2.5. Okay, that's liters per minute. In mLs per kg per minute, the third column, her VO2, she started at 12 mLs per kg per minute, and she got up to about, what, almost 40, right? You see that? So you go, all right, does that mean she's fit? Well, let's pretend it was a max test. Well, 40, again, Galen Rupp is around 80 probably. So, and a cardiac patient is going to be, somebody with heart disease maybe around 15. Average college-age person might be up around 50, 40, 50, I don't know. So I'm looking at, again, we don't know if the 39.5 is her real max. Like, usually when somebody gets off a treadmill like this, after you've recovered, 3 minutes down, I'll say, hey, class, watch this. Like childbirth, I say, do you think you could have gone another minute? And people, they're exhausted when they get on the treadmill. They're ready to fall off, And then after they recover, they go, they could have gone another minute or two. And you go,
But I knew it wasn't a max test.
But yeah, but you could have gone probably more.
Yeah.
Or maybe if it was a running protocol, I would guess that your VO2 max was higher. So even though we're not doing a VO2 max test, I don't know if this is even close. Maybe your VO2 max is 45. I don't know. So we got VCO2. We don't need that. We got METs. We don't need that. She went 11 METs. So she went 11 times resting values. 11 times 3.5 is up there. The RER values are, you look at 0.84, 0.7, so she's burning fats. It gets up to 0.84, 0.85, 0.86, 0.87, 0.9. So again, as the exercise intensity increased, that was that crossover concept. As exercise intensity increases, your carbohydrate increases, your fat decreases. So a high RER is carbohydrate burn. The column VE, that's the one we're interested in. VE, it's minute ventilation. It's VE because it's expired, we're measuring the expired side. And it's BTPS because it's body temperature, pressure, saturated. The machine calculates all that for us. And it's in liters per minute. So from 26 liters per minute all the way up to she was breathing 68, right? So the question is, if I did, what I would do is, there's only 18 numbers. I put these in Excel, those 18 numbers, and then say draw a graph, and hopefully our graph will look something like this. So remember, Excel draws, the lines, so you'd have to right-click on it to get rid of the line, but we just want data points. So I would like to see you guys draw a graph like, right? Remember how to do the data points? If it draws a line, you just right-click and it's a format data series, get rid of the line, and it asks you how big the points, do you want stars, do you want triangles, and I can do that tomorrow if you want. But 18 minutes, I'm not doing it. But you're going to get data points like this, right, on ventilation. So this graph, ventilation versus time, I could do, here's my figure caption. Figure 1, I'm going to call it minute ventilation, or I could just call it VE versus time. That's it, that's a caption, VE versus time. Or I could write words out. I could say minute ventilation versus treadmill time. And then maybe somebody could put, a bulky protocol if they wanted to. I don't know. But I don't want to say figure 1 shows. It's just figure 1, period, caption. Here's what you guys are going to do. This is the big, big picture. You look at this, I've kind of had the line here. So it's, I don't want to bias you. If you see this, everybody's looking at this. Some people are going, I don't know, it looks like there's maybe a line here and a line here. Somebody might say, I think there's a line here and a line. So basically what you're going to do is you're going to take your plot and you're going to, let's see, is there a break point? I don't know what we haven't plotted the data, so I don't know what it's going to look like. But if you have your plot and you look around and you go, oh yeah, here's what I see. I see, and again, it's subjective. You say, I see this, and I see maybe this. So I think I think the break point was at minute whatever 8 or whatever, wherever it is. I don't know, 12 or something. Right? So you're visually inspecting the graph. You might say something different. You say, oh, I think it happened at 15. Right? Or somebody could say, I don't see. All I see is this. I don't see a break point. It's supposed to be the break point is kind of like the lactate threshold. We're kind of saying, hey, this is where you're doing everything fine, and if we're increasing the grade, we're increasing the exercise intensity, so you would expect the breathing to just do this, but it's doing this. And why is it doing that? She's got to buffer the lactate. She's now recruited those fast-twitch bad boys. She's making a lot of lactate. The lactate, we haven't talked about respiratory compensation. We can talk about that tomorrow. But she's got to get rid of the lactic acid buffering. Right? She's building up lactic acid. It's an acid. The body buffers it. It makes CO2. CO2 stimulates you to breathe. You breathe. So it's kind of representing. Again, in the old days, they would call this the anaerobic threshold. That's bad. If we were measuring lactate, we would call it lactate threshold. If it's ventilation, we call it ventilatory threshold. I put here, some people call it, T sub vent or ventilatory threshold. I don't know what the just ventilatory threshold. It's sort of representing when things get tough, right? When she's building up lactate and it has to buffer it. This lab, that's the big important graph. And then when you look at a handout, it says, oh, you can also look at respiratory rate, and you can look at type. So you could plot respiratory rate and see what her breathing did. Did her breathing go up fast at the end, or did it go up fast at the beginning? You could look at tidal volume. So the three columns that are VE, RR, and TV, those are the important ones for us, because it's just RR times, respiratory rate times tidal volume gives us a minute ventilation. So 24 times 1.12 should give us about 26.3. Right? So we can look at how fast she's breathing and how deep she's breathing. Right? That's what those two are telling us. And we can look at heart rate too. You guys can plot if you want. I mean, you could go crazy with this. You could plot heart rate. You can plot heart rate versus VE. You can do heart rate versus time. There's a whole bunch of things you can do to. And again, I'll show you tomorrow. Look at the VE column again, and look at the numbers. This is eyeballing it. I'm not going to plot them on the board. See if there's anything where it looks like there's a big jump. Like I'm seeing 26 to 25, that went down a little bit, 25 to 28, 31. Are there any big jumps that happen?
Biggest one is like 50 to 54. Or 62 to 68.
Yeah, those look like the two biggest ones to me. So I'm just trying to guess what it's going to look like, and where there would be a big jump. And it's either going to probably be, I would guess, maybe somewhere between 13 and 14 minutes, or maybe 17 and 18 minutes. But here's what I want you guys to appreciate. Let's say we don't see any big jumps. Two things can happen. Maybe it's just a smooth curve, or maybe it's just a line. That could happen. Or maybe we didn't go far enough, right? Like maybe if we went another 5 minutes, then we would have seen a jump. But I don't think we did. Okay, so I think we've got data. It's just I don't know what it's going to look like. And sometimes when you're plotting the data points on Excel, if you take your y-axis and you can either make it bigger or smaller, sometimes that'll help you kind of see something that's there. Everybody's going to have a different answer as to where, I think. Maybe we'll all agree. Maybe we'll see this break point and we'll all say, hey, it happened in minute 13, but maybe we won't. So it's one of these deals where it's subjective. There's mathematical formulas that there's a whole bunch of different ways people try to make it not so subjective. When I did it in my master's thesis, I had my graph, my master's advisor had his graph, my buddy had his graph. We all did them separately. We met together and we said, hey, subject A-N, what did you get? And he says 13. I said, yeah, I got 13 too. And, oh, I got a 12. Well, two of us agreed, so let's call it 13. Or if I said it was 11, 12, 13, we'd look at each other's graphs and say, well, no, I think it. So it's subjective, right? So that's the big thing for the lab. There's questions in the lab that I can address tomorrow, but did it indicate a break point? You're going to know. You're going to see. If so, what time did it occur? What was the subject's VO2 at this point? Well, it happens at 13. The minute the VO2 is like, you could say 1.95 liters per minute or 30.2 mLs. So what was the heart rate? Well, we could look at the heart rate. If it happens at 13, we could say the heart rate was 147. And so why would I want to know what the heart rate is? If we're doing ventilatory break point and you're an athlete and I say, we're getting ready for the Olympic trials and you're a 3,000 meter steeplechase person, so we want to train you right at that ventilatory break point because it's going to help train your lactic acid system. It'll do some good stuff. I could say, well, train it around 147 or so, right, or whatever the heart rate is. So that's why you could plot a whole bunch of things, and we could say when you want to train for a marathon or for a 10K, maybe a heart rate of 147-ish is good. That would be close to your lactate ventilatory threshold kind of deal. So that's what that's for. the question is, why does it break away? We already said it breaks away from nonlinear. It's a nonlinear breakaway because of lactic acid, right? We're buffering lactate. Does exercise training, let's say this is we put her on a training program now for 10 weeks. What would happen to her break point, to her ventilatory threshold? It would probably shift to the right. She would reach it later. And that makes sense because then she'd be trained and she wouldn't be building up lactate this soon. And then the fourth one is going to be a tough one. I got to do that in class because that's the one that I give you the answer to, and it's tricky to think about. So we'll do that tomorrow. So we're good to go, right? You guys did a good job with this. I'll grade the tests. I got a meeting I'll grade the tests as soon as I can. And I don't know if you guys want to talk about the test tomorrow or if you want to. Yeah, I'll go grade the test right now, I think, but I'm not going to tell you guys what they are.
Oh, you won't tell us?
Not now.
Tomorrow?
Oh, tomorrow I will. Yeah, it's just I need some time to look at it because if I say, hey, you got out of 35 questions, you got a 10. And it's like, well, wait a minute, I miskeyed some things and I got to make small adjustments perhaps. So if we're good to go, I think it's good to go. I'm going to stand for us.